Hey there! Welcome again to this YouTube channel. In the previous video, we were talking about how to find if a string contains unique characters or not. We discussed two methods, starting from the brute force with time complexity of n squared to the sorting method with its time complexity of n log n. Now, if you haven't watched that video, I'd encourage you to have a look at it. The link would be in the description and in the I button on the top right corner of your screen. As promised, here in this video I'm going to describe the most optimal solution with time complexity of n. So just to recall, you'd have a string such as this, and you have to come up with an approach to return true if the string contains all unique characters, or else you'll have to return false. Since this video is in continuation of the previous one, where I had discussed two approaches, I will name this as approach number 3. This approach is actually pretty simple, What you do is, you take the help of an extra data structure, let's say a list in case of Python, or an array, and make sure that this list contains about 256 false, the Boolean false values. Now, I have taken 256 because in the English language, we have not more than 256 characters, if you'd include all the letters in lowercase and uppercase forms, the numbers, and all the special characters. You would know by now that each character that you see on your keyboard has a special ASCII value attached to it. Like, let's say, lowercase a has 97, lowercase b has 98, and so on. So, the idea here is to maintain a Boolean array for the characters. In this array, or list in Python, the 256 indices represent the 256 possible characters. All the list elements here are initially set to false, and then as I iterate over the entire string, I will set true at the index equal to the integer value of the character, or that means, you understand what I mean when I implement it. If at any time we encounter that the list value is already true, it means that the character with that integer value is repeated. So, alright, so let's jump onto my editor here on the right, and I'm going to create a function named unique characters 3, corresponding to the third approach. Here, I am creating the variable maxchar and store the value 256 in it to represent all the different 256 possible characters. Now, this function that I'm going to create takes a string s, let's say, as the parameter, and here I store the length of the string in the reference variable n, like this. Now, if n is greater than the maxchar, then I return false because I know for a fact that the maximum unique possible characters are only 256. Anything greater than that would mean a repeated character. Then, over here, I'm creating a list, the data structure which will contain 256 Boolean values, and the name of the list is chars over here. So this chars is a list containing 256 false values. And here's the main logic of this approach. I will create a for loop like this, which will iterate through the entire length of the string. And in the loop, I will store the ASCII value of the character from the string in the variable value using the ORD inbuilt function. Whatever the value in this variable be, it would lie between 0 and 255 at that index. And at that index, I will set the Boolean value to true. So, the character lowercase a would be set to true at the index 97. The character lowercase b would be set to true at the index 98, and so on. But every time before I set the values at these indices, I have to check if they have already been set to true or not. So that is why I'd write this if statement over here and return false like this before I do the actual assignment, before assigning them to true. Something like this. We're almost there. Finally, if there are no duplicate values, then I return true, hence finishing my third approach. Perfect. So let's check this function. I'm changing the name here when I call them, changing the name to 3 unique characters 3 like this, running it. Yeah, it is working perfect. So since, as you can see, it is working now. So since we have used only one for loop for the iteration and we are checking while we are iterating, that time complexity would be proportional to the number of characters in the string, hence O of n. But I have achieved the most optimal time complexity. That is fine, since I'm using a list to store these Boolean values. The space complexity is also O of n, corresponding to the length of the string. In the next video, I will talk about an approach where I would solve this problem without using any extra data structure. So the time complexity will be O of n, but the space complexity would be reduced to O1. So till next time, cheerio, and be sure to share it with your friends who might be prepping for interviews. Bye-bye.